graphical analysis of function is basically looking at a function's graph and telling its min-max, where it's going up or down, okay, concavity, all these things. So let me give you all the vocab words. There's a lot of them. And I'll just give you an example. This graph is a pretty good one, a representative example. First thing to note, we always analyze graphs from left to right. Okay, so everything we talk about. Okay, always keep that in mind. Okay, we always list things left to right, we always analyze left to right. If you allow two directions, it just messes with you. It's much easier just to do left to right. Negatives to positives, right? Okay. Graphical analysis. If I were to say, where is there a maximum value, what would you intuitively think?
Or the vertex of the...
Yeah, good math words right there. Vertex of the function. Right there. Yeah, so this would be a maximum, right? So part of analysis is finding a max. Or then we call those extrema. Okay. So maximum or minimum, where are they? I'll show you that tomorrow. Or the next day. Or the next day.
Or never.
Anyways, no, it'll get there this week, but okay, that's one thing we look at. Another thing we look at is increasing and decreasing behavior. You know what those words mean, right? Yeah. Okay, so if I'm going from left to right, is this graph going up or down? Up, right, we're increasing. Right, and then this would be thus, you're going down, right? Decreasing, because we're going left to right. And then this right here would be increasing, correct? And you can write the abbreviated versions. I'm okay with that. Have you ever heard those words? Yes. In mathematics function context.
Oh, okay, no.
Okay, that's good to know. It's fine, you're not supposed to have learned it already. This is all should be new. Okay, we can also do something called end behavior. Okay, that's where does the graph go? Okay. So, where does that one go?
To the ceiling.
Up to what? Yeah, exactly. So the answer there would be the infinite. And then down here, negative infinity, right? That's the crux of end behavior. Okay. We'll get more formal here in a minute on that. But so end behavior is another way to analyze graphs. Okay. Pretty sure that's the bulk of pre-calculus graphical analysis. Make sure. Yeah, critical points and extreme are 3.6. These are critical points. Okay, so where we change from increasing to decreasing, or vice versa. maximum or minimum critical points. Okay. Oh, how could I forget that? Dummy. Okay. The other, okay, are we okay with that?
Yeah.
Okay, the other thing in pre-calc that we look at is continuity. If you looked at that graph, if I said, is that graph continuous?
Yes.
What would you think?
Yeah.
Yeah, it is, because there are no breaks, right? Okay, so does the graph have breaks? Okay, that's the essence of continuity. We will study that more in depth tomorrow. Okay, so that's the pre-calculus graph analysis. Do you want a couple more things that calc adds?
Yeah.
Just FYI, you don't have to remember it.
I do.
Okay. I need a color. Orange. Okay, this. Okay. You know what concave is in science, right?
Yes.
Yeah, we have that in math too.
Like this.
So this would be concave down. Right, because the cave faces down. And this would be concave up. Okay. And then where we transition between the two is called a point of inflection. Okay. So you're experiencing the most vocab-heavy day of your math year. Okay, there's a lot of stuff there, right?
Point of inflection.
Inflection, yep. That's where we change from concave up to down or down to up. Okay, so that's graphical analysis. Every single one of those, when we get in real life situations, can tell us something. And who's in physics? Okay, have you studied gravity yet?
Yes.
Yeah, so when you drop a rock off a cliff, you have a function, right? That can model that.
Drop
Okay.
two rocks off the cliff, they land at the same time.
The slope, so the slope of the function is velocity, okay? The concavity gives us acceleration. There's all sorts of things that we can analyze using this material. And calculus actually makes it super easy. Okay, are you okay with vocab words?
Yes.
Hi. lots of stuff there. Let's move to in behavior. Some people find this hard to imagine. Okay, so because we're talking about something that you're actually not looking at, the infinite, and you haven't studied the infinite a lot. What does x cubed look like for a parent graph? Does anybody remember?
Like Britney Spears? Yeah.
Okay, thank you for that. Nice dance moves, Sherry. You'll never be a Britney Spears. Thank God. Okay, so y equals x cubed. Where does that go? Pos infinity, right? Okay. Here's how you'd say it in math terms. We always have to make it really nice and neat. As x approaches infinity, so that right there is approaches. As x approaches infinity. Okay. That's how you'd say it. So x is getting really big, right? What's happening to the y value? Y is approaching, you already said it, infinity. Okay. This part of the statement is always the same. That is always there. As x approaches infinity is always a part of your statement. The only question is y approaching infinity, or negative infinity, or some number? Okay, that's it. We have to do both sides. What would your statement on this left side be? As x approaches, yep. Again, always the same. What is y approaching? Negative infinity. Okay. That. So you can analyze any graph within behavior. I'm going to show you another one that's a rational function, just so you get an idea what that looks like. Okay. But again, people have a hard time imagining this because we're talking about stuff that's not, you can't see, right? So try to use your imagination and imagine where that goes and state it in math terms. Let's look at, we're good? I'm just waiting for people to stop right now. Rational function. This can throw some stuff at you. What does that one look like? Gang signs. Right. Okay. Yeah, that's my funny gang signs. I guess you can try to do it with your body, but how you do that.
Oh my God, split yourself in half.
Like that. Okay, anyways, back to math.
Why?
Same statements. Again, those are always the same, so you can just count on that. What happens on the left side here? As x approaches negative infinity, what is the y value doing? Remember, it can be positive or negative infinity or a number.
All real numbers.
Where is this headed to? Zero. Somebody said it. But whatever, it just continues to get closer to the y-axis. Will it ever touch the y-axis?
No.
No. So that's a horizontal asymptote. Does that ring a bell?
Yeah. Nope.
Oh,
I don't pay attention very much.
it should ring a bell.
Person drawing. And I still understand what's going on.
Okay, so if you have a horizontal asymptote, remember that's something that this function will never cross. That's your y value that we're approaching. What about the right side? X is approaching infinity. What's y going to? Yeah, 0, because it is a horizontal asymptote. I'm going to spare you what happens in here, because we don't need to worry about it yet. But where's the y value going here?
Negative.
Yeah, negative infinity. So if you wanted to, As x approaches 0 from the left, we're going towards 0, correct? From the left side, y approaches negative infinity. As x approaches 0 from the right side, y approaches infinity. Not going to require you to know that, but this is fair game, what we've written up here. Got it? Okay. You do need a calculator. Go grab one if you don't have one.
That one takes longer than the Yeah, I don't know. 17. People understand if the back says 2 to put it into 2 because now I'll just get that for taking the wrong one.
Oh, get that message. Oh, okay. I thought you just knew where the least was on the wall. No, it was not weird. That was crazy.
Someone took 17 too.
That's fun. I could
You use the code.
Okay, so this is identifying critical points as a calculator exercise for you at this point. Okay, so we'll min and max. Our minimum and maximum calculations will be mostly calculator based, because when you get to calculus, it takes you about 10 seconds to do this work, algebraically. Okay. Let's think of a function here. We'll go with the old standard. You know how to put that in your calculators by now, right? Okay, so put it in your y equals, clear anything else out.
Nope, that's not right.
But you want us to graph it?
Oh my goodness.
Yeah, you're going to graph it. So if you punch it in y equals, graph it. Having window issues? Anybody?
It says error invalid.
Dim? Go into your y equals screen. You see the top that says plot 1, plot 2, plot 3. Are any of them black? Highlight it and hit enter. And now it should fix your issue. You have two lists that are different sizes and it's trying to graph that and it can't compute. So, are we at the graph?
Yeah.
Okay, change your window. Zoom.
Oh.
6. Zoom. 6. If you have a window issue, hit zoom 6. It will fix it. Zoom 6. Okay, so if you have a window issue, zoom 6. All right, so we're all here. Yeah? Okay. You need to find a critical value You want the point. Okay, this one, what is it? Okay, it's obvious, right? How do you do that on the calculator? Okay. Is that a minimum or a maximum?
Minimum.
Okay, it's a min, right? So here's how you calculate a minimum on a calculator. Right, so punch second. No wait, sorry. You don't need second. I'm doing this from memory, so. You just hit the calculate menu, which is right by graph, I think, right? There's a button that says calc on it.
Usually second.
Oh, you do?
Yeah.
Oh, it's the trace, right?
Yeah.
Okay, now I'm operating at full capacity. Second. And that's the trace button. Is that right?
Yeah.
Okay. Okay, that's your calculate menu. Do you see min on there? Okay, go down to min and hit enter. Okay. You will see the bottom of the screen says left bound, correct?
Yes.
Okay. Put your cursor, like the blinking cursor, use your left and right arrows to put your cursor on the left side of where you think the bin is. So just key over there with your arrow keys. Okay, to the left side of where the min is. Okay, and hit enter. It doesn't matter. Just to the left side of it. Who's having trouble?
Right side.
Just to the left side, any point?
At left side, any point. The closer the better, because you're telling the calculator the minimum's in here. Okay. And anybody have trouble with that? Got the left bound?
Yeah.
Yeah, now it's
I know. I think I just go with the white card.
No, go into your trace. Second.
Yes.
You got your left bound. Put your cursor on the left side. Okay. Next it says right bound, correct? Okay, do the same thing on the right side. Hit enter.
Arthur, did we put it anywhere on the left side?
It doesn't matter. Closer the better. Okay. And then guess, yeah. A guess is just that. Put your cursor as close as you can there and guess and hit enter. It'll give you your min.
Just blows up.
Okay. What is your minimum? Yeah. Okay. That's how you find a min or a max with a calculator. A critical point. Okay. We'll go over it again on 3.6. So, are you okay with that?
If we do it.
That was a lot less painful than last time we did calculator stuff. You're getting better. I like it. Okay. So, we have a critical point. At 0, 0, right? A minimum. That tells us the transition between increasing and decreasing behavior. So we need the critical point so we can say where the function is increasing and decreasing. So again, left to right analysis. On the left side here, what's happening? Are we increasing or decreasing? Left to right. Right, it's going down, correct? Decreasing here. Yeah?
Yes.
Okay, so we are decreasing on what interval? This gets. Okay, if I were way out here, what would I call that?
Negative.
Okay, negative infinity to where? Where does the decreasing stop?
0.
0. That is messy. That's called interval notation. Does it look like a point? Coordinate? Kind of looks like a coordinate, doesn't it?
Yeah.
Because of the parentheses.
That's
Not because you're thinking in context of decreasing as an interval.
That's a
Nice distance. Wonder why they're broken. Okay? You could also write it like this. That's an option. Or you can write it like this. That's an option. So you have options. But just keep in mind that this value here is going to be your critical point, right? And where is that function increasing?
Yeah.
0 to what?
Positive.
Yeah, forever, right? Just keep going up. So we're increasing on 0 to infinity, which can also be written. Pretty heavy info. Lots of vocab and lots of new stuff today, right? It's meant to be an introduction. My hope is that next year, if you're in calculus, you would be when you would master this completely. And I can tell you right now that that takes about 10 seconds to do all of this in calculus without a calculator. Okay, it's a lot easier, but it helps to start it this year. Questions on the increasing, decreasing calculator? Okay. Let's say, I'll just give you a graph real quick. Okay, sometimes we're really nice. So we give you a graph. Okay, and they say critical points of f of x are at x equals negative 4 and 1.
X equals what?
Negative 4 and 1.
4 and 1.
Negative 4, yeah.
And 1. It's not a point. It's just x values. Okay.
And
If these are all just x values, do not get those confused. Okay. Intervals and algebraic intervals are all x values. Okay. See how it says x equals? Those are just x's. So negative 4 and 1. Okay. I did not give you the y values, correct? Where is f of x decreasing? See if you can answer that. It's an interval. Yeah. Yep. Bye. Bye-bye, Brooke.
Bye-bye, birdie. terrible. That was the best music. No, it was terrible. It was the best because my brother.
Yeah,
was
1950.
Yeah,
Okay. So, can anybody generate an interval where f of x is decreasing?
Between -4 and -1.
Yeah. From here to here. Right, so -4 to 1. That's an interval, not a point. An interval spans a distance. A point is a location.
Would we do this for a point, like this within parentheses?
Nope, that's a set in mathematics. Okay. So yeah, see how this can be confusing, right?
Yeah.
So think in context. Okay, think in context. If you're talking about decreasing or increasing, this is an interval, not a point. Okay? You have to think through that. Okay, here's a real world example. I can say, I love my wife and I love my parents.
I don't love your wife. But not.
Do I think that that love is the same for each of them?
No.
It is not.
Most definitely.
Definitely not. Okay. So you think, automatically, you think contextually in that, right? With that word, same word, different context, so you think differently. That's what you have to do here. Okay? What about increasing? Where's f of x increasing?
Oh, it's a 3D or something.
Okay, so we have 1 to infinity. And what's that interval?
Infinity to negative.
Negative infinity.
Whatever.
What's that? 4. -4, right?
Come on.
So again, we're thinking left to right, correct?
I can't.
So negative infinity to -4, increasing. -4 to 1, decreasing. 1 to infinity, increasing. Okay. Oh, stop it! Gosh! This is terrible. Okay, that's the sign to be done. Any questions? Okay, tomorrow we'll talk about this again. We'll also talk about continuity. Thursday, talk about it again. Talk about continuity.
Yes.